Today we will discuss about the basic definition of tangent normal and what we mean as subtangent and subnormal. This is applicable in case of Cartesian coordinate only. As we know that in Cartesian frame we have two perpendicular axes x and y, and this is the curve y equal to fx, on which we have the locus point P, which has coordinate x and y, and we draw a tangent PT which meets the x axis at the point T, and obviously this dotted line is the normal at this point P to the curve, and this normal touches this x axis at the point N. Now as P has coordinate x and y, so if this is the origin, we have the abscissa and ordinate as OM equal to x and PM equal to y. Now, what is the equation of this tangent? The equation of this tangent may be written in terms of the current coordinate capital X and capital Y of the straight line as y minus small y is equal to f prime x into capital X minus small x. The point to remember is that in this equation, which is termed as the equation of the tangent, capital X capital Y is the locus point, whereas small x and small y is the fixed value of the point on which the tangent is drawn. If we change this point P and take a point here, the tangent will be obviously different. So this xy is fixed in case of the tangent, and this capital X capital Y is the locus point. Similarly, the normal equation may be written as capital Y minus small y equal to minus 1 upon f prime x into capital X minus small x. So these are the two equations of tangent and normal respectively according to this figure. Now we will find out the length of the tangent, which is actually PT. The length of the tangent is measured as PT, whereas the length of the normal is Pn, while this subtangent is defined to be the projection of the tangent on x-axis, which is nothing but Tm. So Tm is the subtangent of this tangent with respect to this particular point P, and obviously Mn, which is the projection of the normal on the x-axis, is termed as subnormal. Okay, so this is the basic definitions, basic premises of tangent, normal, subtangent and subnormal. I would like to repeat this once again. This is the curve y equal to fx with respect to a Cartesian coordinate x and y with origin at O, and we draw a tangent at the locus point P, which has coordinate small x small y. So OM is small x and PM is small y, and this tangent cuts the x-axis at the point T. So PT is the length of the tangent, and this normal cuts the x-axis at the point N, and Pn is the length of the normal. The tangent has equation capital Y minus small y equal to f prime x into capital X minus small x, where obviously f prime x is the derivative of y with respect to x, which gives the gradient of the tangent. Tan theta is dy dx. This we all know from our initial knowledge of calculus. So whenever we have the curve, we can calculate the gradient or the tangent, gradient of the tangent or the derivative of the function, and write down the equation of the tangent like this, and normal will be perpendicular to this, so it will have equation like this. And here one should remember that capital Y and capital X acts as the locus point of the tangent or normal, where small x and small y is the particular value of the point at which the tangent and normal are being drawn. So with this little introduction, we can easily find this length of the tangent and normals. Let us see how. Just remember that this is the equation of the tangent. Okay, this is the equation of the tangent. And remember the picture also. This was the point P having coordinate x and y, and this was the normal which is perpendicular to this tangent PT meeting the x-axis at n, and we have this to be the perpendicular dropped from P upon x-axis. So this is the ordinate, PM is the ordinate y. So to find the point T, we must put capital Y equal to 0 so that we get the value of the point T, isn't it so? This straight line meets the x-axis at T. So this is the equation of the straight line, equation of the tangent. So we put capital Y equal to 0 here, and then minus putting capital Y equal to 0, we get minus y equal to f prime x into capital X minus x into f prime x. And obviously x becomes, if we transpose this to the left hand side, it becomes x f prime minus y by f prime. So this T point will have coordinate x f prime minus y by f prime comma 0, isn't it so? This is the coordinate of the point capital T, and from this we can easily find the length of the tangent PT, which turns out to be the distance between these 2 points. Just note that if we divide by f prime, this becomes x minus y by f prime, isn't it so? So this is equivalently, this may equivalently be written as x minus y by f prime comma 0. I hope it is visible. Yes, it is visible. So what is the distance between these 2 points? X minus this whole square. So this is y square by f prime square, isn't it so? X minus x plus y by f prime whole square is actually y square by f prime square, plus this is y square. So this turns out to be like this, and this is the length of the tangent, where f prime denotes the derivative of y with respect to x, or the derivative of at p of the function y equal to fx. So this is the length of the tangent. Now let us move on to find out the length of the normal, which is nothing but Pn. So for that we will have to first write the equation of normal. What is the equation of normal? Let us not wipe this out, as we would like to remember this as length of the tangent Pt. This is length of the tangent Pt. Now what is the equation of the normal Pn? The equation of the normal Pn may be written as minus 1 upon f prime x into capital X minus x, since normal is perpendicular to tangent and it has gradient minus 1 upon f prime x. And this equation also gives the coordinate of n when we put capital Y equal to 0, because at x-axis we have capital Y equal to 0, and it becomes minus y equal to x minus capital X by f prime, isn't it so? Y equal to 0 gives this, and from here we can easily find the value of capital X. How? Minus y f prime is equal to x minus capital X, and if we transpose x to left hand side and this to right hand side, it becomes this. So the coordinate of this point n turns out to be x plus y f prime comma 0, isn't it so? And the length of the tangent will be the distance between xy and this. So Pn may be written as, the distance between xy and this point. So Pn will be root over x minus this, so it will be y f prime whole square plus y square, and if we take y common, this turns out to be like this. So this is the length of the normal as opposed to the length of the tangent. Now let us come to the subtangent and subnormal. It's quite easy to see from this triangle, since this is a right angle triangle, this is the hypotenuse PT and this is the base TM, and this angle is tan theta. This angle is theta rather, tan theta is given by f prime x. So what will be the length of the subtangent, which is defined as the projection of tangent on the y-axis? Tm is the subtangent, defined to be the projection of tangent on x-axis. So Tm will be nothing but Pt cos theta. Tm will be nothing but Pt cos theta, because base by hypotenuse is cos of theta, and tan theta is f prime x, and Pt is y by f prime root over 1 plus f prime square. So it can easily be calculated as, let us write Pn here so that we do not forget it. Pn is the normal, length of the normal, okay, and Pt is the length of the tangent. Now tan theta is dy dx, or f prime. Tan theta is, so what will be cos theta? We know that sec theta is equal to 1 upon cos theta, or rather we should write it like this: cos theta is nothing but 1 upon sec theta, and sec theta is nothing but root over 1 plus tan square theta, and since tan theta is f prime, it is nothing but root over 1 plus f prime square. So Pt is like this. So what will be the subtangent Tm? The subtangent Tm will be nothing but, subtangent Tm is nothing but Pt cos theta. What is Pt? Pt is y by f prime into root over 1 plus f prime square into cos theta, which is nothing but, so this is simply y by f prime, subtangent is simply y by f prime. You can easily follow. Pt cos theta is Tm, and Pt is y by f prime root over 1 plus f prime square, and cos theta is nothing but 1 by root over 1 plus f prime square. So they both cancels out and it becomes y by f prime only. So this is the value of the subtangent. Now let us move on to find the subnormal, which is Mn. Mn is the subnormal, okay, the projection of normal upon the x-axis. Now we all know that since this is theta, this is 90 minus theta, and this is all theta, so this becomes theta, isn't it so? Tangent and normal and perpendicular. So if this is theta, this is 90 minus theta, then this will be theta, and this will be, this will be 90 minus theta. Or we may just put it as this is theta, and from this triangle we can easily see that what will be Mn? Mn will be nothing but, if this is theta, so this is perpendicular by base, so Mn by Pm is actually tan theta. So Mn will be Pm tan theta. And what is Pm? Pm is y. And what is tan theta? It is nothing but f prime. So this will be the subnormal. Okay, the length of the subnormal is given by this, and the length of the subtangent is given by this. So in this lesson we have learned how to calculate the length of the tangent, the length of the normal, subtangent and subnormal.